All right, so today we're going to be talking about how to design an experiment or experimental design. And I'm going to attempt to explain the components that will go into designing your own experiment. You guys are going to be doing this week during the block day. You'll also be doing it during some of the other labs. Part of the new standards that are going to come into place that are having to do with designing your own experiment, following it through, deciding what should be tested and how to test it. So I want to make sure you guys have a grasp on how you're going to do this, all right, as we proceed. So first we want to talk about what is a variable. And a variable are any of the conditions that can change during any given experiment. Okay, there's always at least two variables of interest. So example, if I wanted to look at cats, I would want to explore the question, does adding catnip to the diet of cats really change their behavior? Okay, so that's going to be the question that I start with. You always want to start with a question. After I come up with my question, I want then to think about what are the two main variables in this experiment. Well, I'll have to add the catnip in the diet. That will be one variable. And then I'll have to look at the behavior to see whether it has changed. So the catnip in the diet would be the first variable, and the behavior of cats would be the second variable. There are two types of variables. One is called the independent variable, and the independent variable is the variable that you change. So this is the one that you're in control of, okay? So in our catnip experiment, this would be adding the catnip to the diet because I have direct control over this. If you were doing a radish seed experiment, as I mentioned in the previous video, the variable would be whatever you're adding to whatever you're experimenting with the plants. So I gave the example of growing the radish seeds with coffee instead of water. So the coffee would then be the independent variable. Again, the independent variable is the thing you're going to manipulate. It's the thing that's independent of the real life situation, okay? The next variable is a dependent variable. And the easiest way to explain this is that the dependent variable is going to depend on the independent variable. For example, if I'm doing the catnip experiment, then the dependent variable, the thing that's going to depend on the catnip, is going to be the behavior in the cats. This is also something we're going to measure. So the dependent variable is going to be the change we expect to see, and we have to be able to measure it in some way. Now that can be either qualitative, so describing something like the behavior, or it could be measuring something. So in the cats, maybe I'm measuring their activity level. Maybe they're more active. I could measure that. So that would be my dependent variable. In the radish seed experiment, the dependent variable would be measuring the length of the radishes or the stems, whatever, as they germinate, okay? So two types of variables, and it's easy to get them confused. And again, if you can think that the dependent variable is always going to depend on the independent variable, and the independent variable is always going to be the thing that you are manipulating, you are the one that has control over that, then I think, you'll do a pretty good job of remembering when you're doing your experiments. We also want to have what's called a controlled variable, and this is a variable that does not change. So when we do an experiment, we want to make sure that everything in the experiment for the two groups or three groups, however many groups we're experimenting with, that everything else other than the thing that we're measuring and the thing that we're manipulating is the same. So in the cat experiment, the things that we want to be the same across the groups would be the amount of catnip given to the different cats. We would want the type of food. We wouldn't want to change the food across the groups. The breed of cats, because some cats may react differently to catnip. And then also the living conditions, okay? And we try to control these as much as we can. And when we work with living things, sometimes it gets a little messy, where we can't control genetics or how the cat might think, or different things in the blood, things like that. We can't control that, but we can try our best to make the circumstances the same, because then we can compare the different cats with each other. Okay? In the radish experiment, we are manipulating either the water or the coffee, but we want to make sure everything else is the same. So we want to make sure that both sets of radishes get the same amount of sun, that we put the same amount of radish seeds in each pot, that they have the same amount of soil if we're using soil, all those things that we can control. We want to try to make it in the same conditions as possible, because then we know that it is probably the independent variable, the one we're manipulating, that is causing the change in the dependent variable, the thing we are measuring. All right? So in a controlled experiment, which is what you're going to be doing, it's an experiment that tests the effects of one independent variable at a time. So the researcher is going to attempt to keep all the other variables constant, and I'm going to ask you to do this as well, since you are the researcher. Test subjects are divided into a control group and an experimental group. So in the control group, you want to make sure that they're getting the normal everyday condition. Okay, so in our radish seed experiment, that's the regular water. That would be, what they would normally receive. In the cat situation, the control group would be the cats getting just the regular food with none of the catnip added. You might have also heard of when they do drug testing for pharmaceuticals, they have a control group and then a regular group, and the control group would get what we call placebo pills. And in the placebo pills, because we still want them to think that they're getting the treatment, it wouldn't have the drug that we're testing. It would just have sugar or something that's not going to have effect on the person, okay? So here's the control group. So the independent variable is not changed to provide a comparison, and the conditions are set to normal. So again, the cats in the control group are fed a normal diet and are not given the catnip. And so they're going to record their behavior. In the experimental group, that is the group getting the treatment. Okay, so the independent variable is changed, and the results are compared to the control group. If an experiment does not have a control group, then we would say that it is not a valid experiment. And unfortunately, that happens a lot, where a study will be done on groups of people, but they will not have a control group. And then, they'll say, research says, 99% of whatever you're saying. But they didn't actually have a control group, and they didn't see, well, maybe that is the normal condition. All right, sources of error. So after you do your experiment, it's important to reflect upon possible sources of error. So things that can change the result of the experiment. These could be the variation in the test subjects themselves. Again, I mentioned in the cat experiment, these could be just the genetics of the cat. Maybe you tried to control everything, the breed, the age of the cat, the size of the cat, but maybe, it just was a different cat than the one, than another one that was right next to it getting the same treatment. Human error. So maybe someone didn't measure something correctly, maybe someone didn't record something correctly. Human error is a big thing. And in chemistry, we're going to look at human error as the most possible source of error, and you're going to analyze what sources of human error you had on the impact of your results. Poor experimental design. So maybe you had a great idea to test something and it just didn't work out. So you would have to go back to the drawing board and rework that design and then possibly retest it. And then problems with instruments. So not band instruments, of course, but scientific instruments. So maybe the scale was off a little bit when you were trying to mask something. Maybe the beaker didn't quite have the lines to the degree you had to measure to get close enough. All those things could be problems with instruments. All right, so I hope you got enough to begin your experiments. This week you're going to be doing your own experiment, and I really want you to think about all of these things. So having a control group, the different types of variables, and then possible sources of error. And that's what you're going to end up writing up. All right, so hopefully you took some good notes on your note packet, and make sure to do your summary because I will be stamping those on the block day. All right, we'll see you next time.